up chapter 4.1 today. We'll be finishing up chapter 4.1 today. Here's the bell problem. We have to figure out if the graph is a stretch or a compression. So again, we always look at out front of our x squared term. Just ignore the negative sign. If the number is greater than 1, it will be a stretch, and if it's less than 1 or a fraction, it will be a compression. So since 7 is greater than 1, this will be a stretch. So a couple of things we're going to talk about today is our vertex form. Again, remember our vertex is HK, which means our axis of symmetry equals our x value of our vertex. Still the same thing. If the number out front of our x squared term is positive, it opens up. If it's negative, it opens down. The only thing we're doing now is we're moving our vertex away from this parent function of 0, 0, and we can be moving it left, right, up, and down. So looking to see if we move it left and right, we look with the numbers grouped with our x term and it's being squared. If it is x minus h, we move to the right, h spots. If it is x plus h, we move to the left that many. And then we have something added or subtracted outside of our parentheses, not grouped with our x. That's where we move our y value to. And if it's positive, we move up, and negative, we move down. So if you notice with our x values, it's kind of opposite. Since it's minus, we move to the right, and plus, we move to the left. You got to think opposite. So first, we need to graph each function. Again, notice how something is subtracted, but it's not grouped with our x value, so we go down 5. We move our vertex down 5. And then we have to plot a couple more points. And if we were to plug in negative 1, we would get negative 4. If we were to plug in 1, we'd also get negative 4. If we were to plug in 2, we get 2 squared, which is 4, minus 5, we get negative 1. And the same thing if we plugged in negative 2. And if we plugged in 3, 3 squared is 9, minus 5, we get 4. And the same thing for negative 3. So again, notice how if our vertex stays on the y-axis, we can just reflect points over. So connect all your points, make sure it kind of has a curve to it. And then you're done. So the only transformation for this graph would be down 5. Looking at the next graph, notice how it is grouped with our x this time. So that means we're moving left and right. Since it is minus 4, remember you got to think opposite, so we move to the right 4. And then we just got to plug in values. If we plug in 5, 5 minus 4 is 1, 1 squared is 1. Plug in 3, 3 minus 4 is negative 1, square it, we get 1. Notice how it is reflected. Plug in 2, 2 minus 4 is negative 2, square it, and we get 4. And plug in 6, 6 minus 4 is 2, square it, and we also get 4. Connect your points, and we're done. Notice how what our transformation would be. We moved our point from 0, 0 over to 4, so our transformation would be right 4. So go ahead and graph these functions. So for the first one, we'd be moving our vertex up 3, so it would be at 0, 3. So the transformation would be up 3. Plot your points, connect your graph. And on the second one, we would be moving to the left 1. So our vertex would be at negative 1, 0. Plot some more points, connect your points, and our transformation would be left 1. Now, we can do all of this without even graphing our function. Again, remember, we can determine our vertex with the numbers that are added or subtracted, our h and k. So we first start with h, since that's our x value, and we take the opposite sign. So our vertex would be at 4 for x. And since it's subtracted 2, we keep the same sign, so we're at negative 2. Remember, axis of symmetry is always x equals. And it's always, since it's x equals, it's always going to be the same value of the x value of your vertex, so that would be 4. Next, we have to determine if it's a max or a min value. So, looking at the number out front of our x squared term, since it is positive, our graph will open up. which means our vertex will be the lowest point of our graph, so we'll have a minimum. And remember, the minimum or maximum value is always the y value of your vertex, so that's negative 2. Now, we haven't talked about domain and range yet, but domain is the x values of our function, and since parabolas extend forever and ever, they would be all real numbers. Remember, you can represent that with this letter r. So that'll be true for all parabolas. And then our range is our y value, so it'll always be y. And then we have to determine, say this is the lowest point of our graph, and our y values go up, that means it's going to be y greater than or equal to. And it'll always be the y value of your vertex, since that's the lowest point our graph goes for this one. So it'll be y greater than or equal to negative 2. So go ahead and determine all of these for this next function. So our vertex is negative 1, 4, which makes our axis of symmetry x equals negative 1. We'll have a maximum since we have that negative out front, and that point will be 4. Again, your domain will always be all real numbers, and your range will be y less than or equal to 4. So we then need to graph this function. Again, plot your vertex. So our vertex will be 1, 3. And then we have to figure out some more points. So if we plug in 0, 0 minus 1 is negative 1. Square it, we get 1. Multiply by negative 2, so we have negative 2. Add 3, we get 1. And again, we can reflect that point over. So since we went down and to the left, we can go down and to the right. And we have 3 points, so that's good enough. Connect your points. And we are done. So if I asked you for the transformations of this graph, you would say right 1, up 3, reflection, and stretch. So the last part is to figure out the transformation. Again, notice how we moved our vertex. We have a reflection because of the negative, a stretch because it's greater than 1. So you have to figure out which one of these would be correct. And I would go with D, stretch by a factor of 2. It reflects across the x-axis because of the negative. We translate it 1 unit to the left, since inside is positive, we think opposite, and 3 units up, since it's plus 3 on the outside. So the answer would be D. Come in class ready to graph tomorrow.